So I believe that you have seen the marking scheme. And especially for question number 3, okay, some of you did not calculate two values and the TA did not give you the marks. And I told the TA that as long your final answer is 2.346, okay, you will get the 2 marks. Are we clear? Okay, so I have a lot of emails coming to me. Okay, so TAs are very strict. They are not flexible. Okay, so most of the time when I see your email coming to me, so for question number 3, if your final answer is 2.346, okay, you'll get the full mark. Are we clear? Can you help me check? Yes or no? Okay, so don't email me, okay? Email who? Email the TA. And do you know who the TAs are? Okay, so some of you ask me, Eugene, who is my TA? And all you need to go is go on to Avenue to Learn. Okay, so if you go to Avenue to Learn, which is on 2Q, all you need to do is go to the welcome. And on the welcome, these are your TAs. Are we clear? Okay, a lot of you know who your TA are, but some of you that don't, this is how you handle your TA. Are we clear? Okay, so these are the TA and based on your last name. Okay, so please contact your TA. If you contact me, I will tell you go to your TA. Okay. Now, I discovered something very interesting, and I think I need to teach this. My colleague in mechanical say no, it's too much for them. I say no, they have to know. Okay, so I'm going to look into this problem again. Okay, how come I cannot copy the? Okay, bear with me. Let me relaunch. Okay, I'm going to look at this problem again because there's something that I discovered that I think you have to know, not know later when you are in upper years. I think you have to know now. I was talking to one of my colleagues regarding this issue, and he said like, no, they are still too young to learn, know about this. They're not experienced engineer. No, I think you have to know. Okay, so what do you have to know? Okay, so this is our okay, so what is this thing that I want you to know? We have solved this problem before. Okay, again, we have solved this question before, but there's something important that was not explained properly. And what this is to solve this problem, right? Right, we have to find, let's recap this problem. We have to find VC. Okay, we have to find what is our VC. In order to find VC, we have to what? To find, so the equation to use for VC, we are going to use VC is equal to VD plus by omega CD cross R C from point D. Okay. In order to solve this equation, we have to what? Determine what? We have to determine BD. Okay, we have to find what is BD. And there are different ways to find BD, but there's only one correct answer. Okay, there's one correct answer. So we have to determine. So to determine VD, we have to consider the rigid body ABD. Okay, we have to consider the rigid body ABD, and we know that omega AB is equal to omega BD is also or equal to omega AD because of what? The angular velocity or the what? The same. Are we clear? Okay. So on our mind, so this is where I think I make a mistake on the first time I show you, and I did not know why. Then later on when I reflect, I say, yep, this is the reason why. Okay. And the reason why it's critical, and you might not see a problem like this for a while, maybe in your upper years or as experienced engineer, but this is important. So case number 1. Right? So as a student, case number 1 is you can consider 2 points. Okay, so you can consider point A and point D. Yes or no? Right? You can also consider case number 2. You can consider point B and point D. Right? You can also have another consider case number 3, where you can consider point A and point B. Which is the correct one to pick? There are 3 possibilities. What we are going to determine from all this, we can determine what? Omega AB. Which is equal to what? Omega BD, which is equal to omega AD. Okay. So I'm going to write to you what happens. Okay. Because in your term test, you cannot say, Eugene, they're all on a rigid body. I take this point, this answer has to be correct. Okay. But the critical part is this. Okay. Which points to consider is critical. And I did not do that the last time, and I have to apologize to you. Okay. Let's look at over here. Okay. So now let's consider case number 1. Okay. We look at point A and point D. Okay. We look at point A and point D. We know over here we have VA is equal to minus 4J. Okay. And then at point D, right, we know that VD is coming down. Sorry, VDJ is coming down. Right. And we're going to assume VDI is going in this direction, and this is our vector for VD. Okay. Okay. So the only thing that we are not sure, this one we assume. Okay, we assume that direction. So we write out VD is equal to VA plus by omega AD cross R D from point A. Okay. So we know that over here, this is our omega AD direction. Okay. That is our omega. So we form this out. We write this is equal to VDI minus VDJ. And the whole thing will be equal to minus 4J. And we have plus, and then it's minus omega AD K, right? Because this is in a what? We assume it, not assume, yeah, we assume it to be in a clockwise direction. Cross RD from A. So this is equal to point D from point A, 0.25 or 24I. Okay, and then you get plus 0.18J. Okay. So now we have our I component. So I component, you have VD, and this will be equal, oh, sorry, I cannot do I component first. I need to do the cross multiply first. So VDI minus VDJ is equal to minus 4J. K cross I is positive, negative, negative is positive, so plus by 0.24 omega AD, and this will be J. K cross J is negative, negative and negative, again, we have a positive plus by 0.18 omega ADI. So from here, we have our I component. And our I component will be VD. And this will be equal to 0.18 omega AD. Equation number 1. Then if you now look at the J component, you have minus VD. And this is equal to minus 4 and plus by 0.24 omega AD. This is equation number 2. I made a mistake on Thursday saying that we cannot use this equation to find VD and omega AD. You could. I repeat again, you can. Okay, so equation 1 and 2 can be used to determine omega AD, or to determine omega AD and VD, right? So when we use this, we have what? Minus 0.18 omega AD is equal to minus 4 plus by 0.24 omega AD. Okay. So if we move things around, so we have 0.4 omega AD, and this will be equal to 4. So from here, omega AD, we know will be equal to 9.523 radians per second. Okay, so 0.4. Sorry, 0.42, not 0.4. Rushing again. I need to come down. Okay, so 4 divided by 0.42, 9.424 radians per second. And from here, we can find the I component for VD in the I component is 0.18 times by 9.524 is equal to 1.714, right? Meters per second. And then the J component, we have minus VD, and this is equal to minus 4 plus by 0.24, 9.524. So minus VD is equal to minus 1.714 meters per second. So over here, we get VD in I and J. So this will be equal to 1.714 I, and then will be equal to minus 1.714 J. Okay. Now this is VD equal to 1.714. Now over here, the VD is positive, means this assumed direction is correct. Are we clear? The assumed direction is correct. Yes. No. Wait. Over here, if this is positive, means the assumed direction is correct. The assumed direction is coming down. VDJ is coming down. So that's why VDJ has to be negative. Are we clear? Okay, so hear me out. Thank you so much. Okay, now, this is one set of value that we get. Okay, now let's consider another point. Let's consider case number 2. Okay, or let's make life more interesting. Okay, let's consider case number 2. You guys are mumbling. Is there any question or point of view that you want to say? Are you okay? Yes. Say it again. VDI. I did not assume them to be the same. VDI is one component, VDJ is another component. They're not the same. Over here,